All right, hello and welcome. Yay! Welcome to our algebra class. This is Aurora with Supercharged Math, and I have a few winners. Can we announce winners really quick? Okay, so remember, if you are participating, you are simply putting your work in. You are submitting them to me by email or to the private student Facebook group, which I prefer, so you guys can each see each other's work and get totally inspired and have a lot of fun. All right, so I pulled two winners randomly. I put everybody's name in a hat and pulled them out. I have two. So give me a big old drum roll. Dun, 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 dun. Give me a cymbal crash, and I am still pulling up their names. So we are going to get in touch with you. So these students are going to win. Here, I'll tell you what they're going to win as I'm working on this. They are going to be winning a packet, which I will be sending in the mail. So this packet's going to come to you. It's got my favorite engineering ruler, one of the magic one of my favorite double dice is going to be in there, as well as the math award pin. Three. Okay, so give me a big old drum roll. Ready? Drum roll. Cymbal crash. 3, 2, 1. Winner number 1 dun, 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 is CE. Yay! And winner number 2, drum roll. Cymbal crash. Winner number 2 dun, 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 is CR. Yay! All right, so remember, these were randomly picked, and I am going to be in touch with, so if you guys want to get in touch with me, that would help too, but I have your contact info, so my team will get in touch with you. There's no charge, and I will give you the packet in the mail, just as my way of saying, hey, thanks for being part of the program. How would you all like a prize? Would you guys all like a prize? Wouldn't that be fun? Oh, let me think. How about I lock you in a room, and you try to escape? Would that be a fun prize? Guess what we're going to do today? Yes! Okay, so there is a packet that, actually, do you have a packet? Hang on. Let me grab my notes for today's class, and we are going to go ahead and get started. If you can go ahead and tell me, give me a shout out, a hello. I can go ahead and say a few hellos out. Make sure you also include where you are from if you're outside the United States, so I can get that hello directed in the right area, right? Okay, so let's go ahead and start our official start. Dun, dun, dun. 3, 2, 1. Hello and welcome. This is Aurora with Supercharged Math, and we are doing a lesson in algebra today. We are continuing our discussion from last week on multi-step equations. If you missed that, no problem. You can still catch on with today's topic. You're going to need a pencil. You're also going to need your notebook, and if you printed out the packet that I put together for you, you're going to get that out. Now, if you don't have it, please don't panic. You can still do today's class without the panic. Yes, please, without the panic. You can also do it without the packet. Here, I'll make it nice and big. And so I will give you about 40 seconds on this slide. If you need the secret student packet, go ahead. You can use the bit.ly link. You can use the QR code. That'll work too. But again, don't stress. If you don't have it, you can do today's class entirely without it. So today's going to be a bit of a review. We're going to go over lots and lots and lots of problems in multi-step equations, all different kinds, because, well, problems are all over in math textbooks, right? Okay, there's a lot of jokes about that as well. All right, so go ahead and get your student packet out if you have it. Again, if you don't, you're grabbing a pencil and a journal, and here we go. 3, 2, 1. All right, let's go. So first things first, you got your pencil? Somebody's asking why I use Sharpie. I use a Sharpie because it shows up better on the screen for you. Like if I use pencil, here, I'll show you some pencil. See how it doesn't look at, it's hard to read. It's really faint. So yeah, so that's why I'm going to use a Sharpie. But you are using a pencil. Okay, so first things first, we are going to get lost in a maze. How do you feel about mazes? Yep, so it's going to be one of these. So you're going to start here at the top, and we're going to work through the maze together. If you don't have it, again, you're not going to worry about it. I am simply going to write down the problem for you, and then we're going to work on it together. So 5x plus 3 equals 8. Okay, so rarely in the real world do math problems walk down the street like this. So we are already assuming that you know how to put this down on the paper, which you don't. And so what we're going to do is we're going to practice this, and then what we're going to do is we're going to show you how do we actually get this on the paper in the first place. So that comes from a word problem. So the first thing we're going to do is practice getting the solution, solving for x, because x is something we don't know. Algebra is also all about finding out things we don't know, okay? And We're going to solve here for x, and then shortly, we're going to start introducing word problems where you'll learn how to put this on paper. Okay, first things first, you got to get x by itself. So if you're tempted to divide by 5, that's not the first thing I want you to do. The first thing I do want you to do is to take that 3 and throw it over there by the 8. And we do that by saying, how do we get rid of a 3? If I had 3 cookies and I said, could you get rid of these for me? You'd say, yeah, no problem, right? You would eat 3. Anytime you do something on one side of the equation, you must do it on the other, right? You ever babysat 2 little kids and tried to give one a cookie and the other one you don't? Somebody's going to be crying, right? So whatever you do, equations are the same thing. They're big babies sometimes. All right, so same thing on one side of the equation as the other. This goes away. That goes to 0, so we'll cross it out. 8 minus 3 is 5, okay? And I'm going to drop this 5x down because I didn't do anything to it. It just goes straight in there. Then what we're going to do is we're going to say now we want the x by itself. I can't say minus 5x because then minus 5x will pop up over here and that doesn't help. Instead, what we do is anytime you have a number in front, we call this a coefficient, and coefficient, okay? What we want to do is we want to get that equal to 1. So how do you make a 5 equal to 1? Easy. You divide by itself, right? A number divided by itself is 1. Remember, you got to do it to this side too, okay? 5 over 5 cancels. X is equal to 5 over 5, which is also known as 1. What does this mean? This means if I put a 1 in here, I will get 8. 5 times 1 is 5 plus 3 is 8. So x equals 1 is a solution. We call it a unique solution. X can't be 2, can't be minus 1, can't be anything else. It has to be 1. 1 is the only number that makes this statement, the original black problem in black up here, true. Okay, so x is 1, so what do we do? So that means we did this one, and now we're going this way. So here's our next problem. So not this one, not this one, but this one, okay? All right, so let's write down that second one. So the second problem is x plus 2 over 2 equals minus 1. Okay, what do you think we should do first? How do you think we should handle that? How do you think we should handle that? Yeah, I would get rid of the 2 first. So what are we going to do? How do you get rid of a 2 on the bottom? You multiply it by a 2 on the top, right? 2 over 2 is 1. But remember, you got to do it over here too. So I'm not going to be using this x because doesn't that look like an x here? And it's confusing, isn't it? So what I will do is I will either put a dot or I'll put this thing in parentheses. So that's how you know it's multiplication. So this is a minus 1 times 2 is how I'm reading this, times 2. So I'll put parentheses here. So now there's no dot, okay? So that way you know they're multiplied together. All right, so these go away, and I am left with x plus 2 equals minus 1 times 2 is minus 2. Okay, we're going to throw that 2 on the other side. That goes away. X equals minus 2 and minus 2. This is I owe $2. Now I owe 2 more. So these don't cancel. They have the same sign, so they go together. And they combine to give you x is minus 4. So what does that mean? That means if I put a minus 4 in here, I will get minus 1 out of this. So minus 4 plus 2, here, minus 4 plus 2 is a minus 2 on top. Minus 2 divided by 2 is minus 1. Good. So this is a good way to check your answer to make sure you didn't make any mistakes. The biggest mistake you'll find in just about every algebra class is people dropping their minus signs. They'll just write down 2 instead of minus 2. So if you tend to write really small, that's going to happen. So write nice and big on your page, take more paper and more room than you usually do, and you'll find you're going to make less mistakes. Okay, good. So -1. So on your maze, you can mark it off, and then I'll write down the next problem while you do that. Okay. All righty. So what do we have? Okay, so we have a -6, a -2x, and a 10. So let's put this on the other side. Let's get this over there. Okay, so we're going to say plus 6 plus 6. Okay, so we'll rewrite the problem. -2x, because I didn't change that, equals, this is 0, so go away. 10 plus 6 is 16. All right, now what do we do? There's a minus sign there. That's okay, you're not worried. All you do is you divide by whatever is in front of the x, minus sign included. So we're going to go minus 2. And then whatever I'm dividing this side, you can already just slap it down there, minus 2. It's got to be the same. Otherwise, you're changing the problem, and you won't get the right answer. You'll find a value for x that doesn't actually make it true. Okay? So whatever's in front of the x, that's what you divide by. Good? And if it's down here, then that's what you multiply by. You just want to make it equal to 1. So minus 2 over minus 2 is 1. Right? This fraction would be 1. If I gave this to a 4th grader, they'd say, oh, that's 1. Okay, so then we have x equals, there's only one minus sign, so 16 divided by 2 is 8. Okay, because there's an odd number of minus signs that stays there. Good. All right, so how are you feeling about this so far? Remember, we're just going to practice we're not going to do any new content. We're just going to practice the multi-step equation. Multi-step means you just didn't do one step, right? So if this was just plus x, then we would have just found x was 16, right? But multi-step means we have to add or subtract, and then we have to multiply or divide to get your answer. Good. Okay. So let me write down the next one for you. Okay. What do you do if it looks like this? Okay. I'm going to go grab a water, and you are going to work on this one for a minute. Go ahead and work on it right now. I'll be right back. All right, what'd you come up with? Did you move the 7? Yeah, you need to move the 7 first. Don't even think about touching the 5. Okay, so let's do this one together. So I want this positive 7 over there. So I'm going to say minus 7, minus 7. Whatever you do on one side, please do on the other side. How do we get the x by itself? So this is x divided by 5. So I'm not going to divide by 5 because that would just be a 25. I'm going to multiply by a 5. Multiply by a 5. Do you see how 5 over 5 now equals 1? This thing is 20. So x equals 4 times 5, which is 20. And if we put a 20 up here, 20 divided by 5 is 4. 4 plus 7 is 11. You can see that we actually get the right answer. Okay, and this statement is true. Okay, so how are we feeling so far with that? Here, pause for a second. Okay, how are you doing with this so far? Doing okay? Okay, we're going to do lots of examples so you're comfortable with it. And you see, the best way to get good at doing math problems is to do math problems in what it is that you need help with. So we're going to do a lot of them. Okay, so the next one is a minus 5 equals a 7 plus 3x. Okay? Okay, so first things first, deal with this guy first. Put him over there. So it's going to be a minus 7, minus 7. Okay? So this is a minus 12. This goes away. Equals 3x. Okay, now get the x by itself. How do you do that? That's the name of the game, getting x by itself. Need some alone time. Okay, so what am I going to do? Yeah, I'm going to multiply by a third, somebody said. That works. That's exactly what we want to do. Multiply by a third or divide by 3. It's the same thing. Okay. And then you tell me, what do we get? Yeah, the 3's go away. And by go away, I mean the 3 over 3 equals 1. So now I have 1 times x in the front equals, there's only one minus sign. That's an odd number, right? If they were both negative, that'd be an even number of minus signs. So it'd be positive, but there's only 1. 12 divided by 3 is 4. So the answer is minus 4. Okay. So do remember, if you've got questions as we go through, you're typing them in the box, you're typing them in the chat. You can always send me an email, Aurora at superchargedscience.com. I can see lots of people filling in the chat right now. Yes. So I am trying to answer these as many as I can. Okay. All right. Let's do another one. Okay. Let's see. We are on this one. Is this right? X minus 6 over 3 equals minus 4. Let me bring that down. Okay, so what should we deal with first? Well, we got to dig the x out. And so for me, I would say get rid of that 3 first. Put the 3 over there. And then we can put whatever the 6 over there, right? And then we have the x, and the x doesn't have anything in front of it this time. Okay, so we're going to get the 3 over here, but to do that, we're going to multiply this entire thing by 3. Multiply the entire side of the equation by 3 on both sides. Because we do it to both sides, it doesn't change the problem. Okay, so then the 3's will cancel. So I'm left with an x minus 6. Okay, so that's how we get rid of the 3. But it pops up over here. It's like one of those whack-a-mole games, right? As soon as you get rid of 1, it pops up somewhere else. So it's got 1 minus sign, so it's minus. 4 times 3 is 12. Are we done? Not quite. So what we want to do now is we want to get this over here because we just want x. We want to know what x equals. This says x minus 6 equals minus 12. Well, that doesn't help us. What does x actually equal? Just tell me the answer, right? So we have x, let's see, I'm going to say plus 6 and plus 6. So x equals, so minus 6 and plus 6 go to 0. So the 12 is bigger, right? So the minus sign stays. Okay, I owe $12 and I paid back 6. I still owe $6 more. Okay, so that you take the difference when the positive and negative are different, when these are different signs, positive and negative. Good. And then whatever the bigger number is, that's the sign. Okay. All right, so this says if I put a minus 6 up here, minus 6, this is a minus 12. 12 divided by 3 is 4. Minus 4 on this side, and that's a minus 4. So I actually get that back. Here, I'll show you. So if I say the original problem, x minus 6 over 3, what does that equal? And if I found out x is minus 6, I'll say, okay, so where there's an x, I'm going to put a minus 6, and then I'll just write the rest of the problem down. Okay, this is what x was. Minus 6 and minus 6 is minus 12, and then divided by 3. 12 over 3 is 4, and don't forget your minus sign. So this says this equation will equal minus 4 when you stick an x equals negative 6 in, and that's what we get. So that statement is true. X has to be minus 6 in order for this statement to be true. Okay, good. Good question. Somebody was asking about that. Good. And yeah, I do plug numbers back in, so I check my answers, so I can check myself. Yeah, I do that all the time. Very good test-taking strategy. Okay, the next one is 4 plus 3x equals 19. All right, so do you remember how we were doing problems before? Let me grab a piece of paper. We were doing problems, and I would say x minus 1 equals 2. And then you could just do that in your head, right? You could say, okay, or you could say, well, if you just subtract 1, then you get 2. So of course, x has to be 3, right? That makes sense. So you have a certain amount of cookies, you take away 1, you get 2. So it makes sense. Or if I said x was, let's see, 2x equals 4. 2 times something is 4. What is that something? And you're like, well, I know that. That's easy, right? 2 times 2 is 4. So x has to be 2 in this case, right? Okay, that's what makes the statement true. So you're doing these in your head. So when the problems start to get harder, we can't necessarily do these in our head. So we use algebra to help us figure out, well, what does that unknown have to be, right? Okay, so let's see. So we're going to get rid of the 4 first. Okay, so the procedure for doing this is getting everything not attached to an x by itself, all the whole numbers. Okay, and when you get more advanced, these will be decimal numbers. Okay, so this is minus 4 and minus 4. So we have a 3x equals 19 minus 4, which is 15. Okay, and now we still have 3 times something gives you 15. You can probably already tell me that if you know your multiplication tables, right? All right, but let's follow it through, because maybe if this was 3.2, right, instead of just 3. So let's just follow it through. Whatever's in front of the x, you're going to have to divide. Whatever's in front of the x, you're going to divide both sides. That becomes 1. X equals probably what you were shouting at me. It was 5. Right? 3 times something gives you 15. It has to be 5. So this is how we go from doing it in our heads to doing it on paper. Good. So if I put a 5 in here, I will get 19. Okay, this statement will be true. Good. X is 5. Good. Okay. Let's try one that's a little wonky. You know, as a student, when I was in math class, and I would always get frustrated that the teacher would do all the easy ones, and then I'd go home and do stuff like this, and I'd be like, what? I have no idea. The teacher didn't do anything like this, right? So I want to do as many difficult ones as possible so you're comfortable too. Okay, so let's get this over here, and we do that by saying plus 2, plus 2. Okay. All right, now if you're wondering why didn't we say plus 2 over here, we did. So everything on this side of the equation, okay, we're just going to add 2, and then everything on this side of the equation, we're going to add 2. So we do it on either side of the equal sign. Okay, so this goes away, minus 2 and plus 2. So we are left with x over minus 3 equals 11. Okay, what do we do now? Well, we haven't had one like this, but do you have an idea? Yeah, what if we multiply both sides of the equation by whatever is on the bottom? What do we get? Minus 3 over minus 3, that goes to 1. X equals, and what's this business? Yep, there's only one minus sign, so bring it out. 11 times 3. That's easy on the multiplication table, right? Yeah, so x is minus 33. Good. How are you doing on your maze so far? How are you doing on your maze? Yeah, we're almost halfway done. Good. Okay, let's do another one. All right, so the next one I have is minus 6x minus 13 equals 83. Ugh, right? Okay, let's hope these numbers work out nice. So we're going to take this and go over there. And I'm going to give you 20 seconds to tell me what x equals. Okay, I got you started. I gave you the first step. And then go ahead and tell me, what does x equal? You think you got it? All right, if you're still working, I'm going to be quiet, and I will just write it up here, and then you can look when you're ready. How's that? Okay. So I won't talk my way through this one. Okay, 96 divided by 6. Do you want some help with that one? I'll just tell you that's 16 if you don't know your 20 times tables. That's fine. A lot of people don't. That's okay. All right? If you got this far, that's brilliant. That's perfect. Yeah. This was just big number. Good. All right. So the first thing we did was we brought this over there, and then we just divided by whatever was in front. That thing went to 1. Good. Okay, you ready for one that doesn't have such a big number? How about this one? What if it looks like that? What do we do then? Okay, so the first step is going to be this. Get that over there. How are you going to do it? Okay, I'll give you about 20 seconds. Go ahead. Oh, did I forget my negative sign on the last one? Somebody's telling me. I did. Look at that. I just dropped it. Sorry about that. Okay. So yeah, should have been negative 16. All right, I'm going to just work my way through this one. Again, I'll be quiet, so if you're not ready, don't look at the screen. Okay, so here we go. Somebody's asking what this kind of math is called. This is called algebra. Okay, you about ready? All right, so if we look at the original problem and we put 4 for x, excuse me, 10 plus 4 is 14, divided by 2 is 7. So x has to be a positive 4. All right, let's take a look at the next one. So this is, I think, the 11th problem we're doing. So we have a minus 7 equals minus 11 plus x over 5. Okay, so did you notice on the last one how the whole thing was over 2? And I said, okay, deal with the denominator first. But do you notice how it's only x now that's in the fraction, right, divided by something? So you don't have to deal with that first. Deal with this first, okay? So if it was minus 11 plus x over 5, like both of them were over 5, then you would deal with the 5 first. But you're not. You'd have to deal with 11 first. So we're going to add 11 to both sides. Okay, this goes to 0. We have an x over 5 equals, okay, and positive 11 minus 7. So it's going to be positive. All right, it's going to be positive 4. Okay, so how do we get x by itself here? All right, well, there's a 5 on the bottom, so we're going to multiply both sides of the equation by 5. And remember, I can do that because I'm doing it to both sides. It won't change the thing. So it's like saying if I have a, let's see, if I have a 6 over here, 6 equals 6. Right? If I only multiply one side of the equation by 3, well, now I've got 6 equals 18. That makes no sense. I have to multiply both sides of the equation for this to hold. And so that's why we're doing it. Okay, so this is positive 5 times positive 4. Okay, not 5 plus 4, but you have to remember what you're doing. You've got a number on here. It's positive 4. You're multiplying it by 5. So I have a 20 equals x. Okay, because that goes away. Good. All right. I want you to take a break. Stand up. We just did 11 problems. I know. We have a few more to go. Stand up, stand up. Take a quick stretch break. All right. Get a bite. Take a sip. You're doing amazing, by the way. Amazing. I know. And I actually have some really fun activities for you today, which include really fun things that projects we're going to do. We're going to do a fair. We're going to do, you're going to come up with your own games this week and your own really cool demonstrations. I have some new labs. We have lots of really fun stuff we're going to be doing. So, all right, stretch. You ready? Okay, so when you're ready, come back. And we're going to take a look, and I want you to start the next problem. Can you start the next problem? I should probably be writing it down, though, in case you don't have the worksheet. Okay, so the next problem is this one, when you're ready. Okay, if you need a little stretch, that's fine. Stand up, wiggle out, wiggle around a little bit, okay? And then when you're ready, there's the next problem, okay? All right, I'm going to take one more little break for a drink of water. Okay. All right, back down to business. We got a few more to finish, and then we can start playing a game. Okay, you ready? So, well, actually, we kind of are playing a game. We're kind of working our way through mazes. Okay, so do you want to deal with should we divide by 7? Somebody wants to divide by 7. You can. You get a bunch of yucky numbers, though, if you divide everything by 7. That'll get the x by itself. Here, you want to try? All right, minus 20, that's going to be 24 over 7 equals 7x over 7 plus 18 over 7. Okay, x equals, this is so not how I would do this, x plus 18 over 7. And then you would divide by 18 over 7. So this is the fun part about math. You're like, I don't know, let's just try it. So that's going to go away. And then you would have to combine these. And it does work. It does work because, the math can handle it. I'm going to get 24 and 18 is like 22 and 20. So this is minus 42 over 7. And that reduces to x equals a minus 6. Okay, so you could do it that way. Does that look like a big fat yuck? Yeah, it looks like really yucky, doesn't it? Okay, let's do it. Let's do it the way I would do it. Ready? So minus 24 equals 7x plus 18. All right, we had our laugh. Okay, so I would put the 18 on the other side first. Keep the 7 locked up with the x, okay? So minus 18, okay? And then what do you get here? What do you get here? So they're both the same sign, so they're going to combine. So this is going to be a 42 equals 7x, okay? And then you're going to divide both sides by 7. That goes away. And now we have x equals 42 divided by 7 is 6. I dropped a minus sign, didn't I? Yeah. See? Even teachers do it. Put it there. Minus 6. There we go. Positive x equals minus 6. It's a minus sign. Good. All right. How do you feel about that? You like that one better than the one with all the fractions with the 7s on the bottom? Yes, definitely. Okay, great. Let's try another one. Okay, minus 3 plus 4x equals 5. All right, what do we do first? Can you do this one? Okay, don't look at the screen. You copy this down and then work on it. Okay, and I'm going to do mine off screen and we'll see if we get the same answer. Okay, here we go. Okay, go ahead. And box your answer when you've got it. Okay, don't look at the screen if you don't want to see it. Did you get it? Yay! Good. Somebody's asking, can I race ahead? Yes, you can absolutely race ahead if you'd like. That's why I gave it to you in advance. Okay, we just have a few more to go. 8x plus 10 equals minus 6. You want to race on this one? Okay, ready, set, go. Okay, when you're ready. There we go. It says on the, where did you get the 11, the minus 11? Oh, let me see if I can find that one. Minus 11. If you can tell me which problem it was, that would be helpful. I'm looking through all my notes now. Minus 11. Okay, if you can tell me what problem that was you had a question on, is it Emory? Okay, great. All right, good. Did I show you the answer? I think I did. Yes. Okay, let's do a couple of more, and we'll go a little bit slower to make sure we're not leaving anybody behind here. Okay, so this is one, x plus 4 over 7 equals minus 3. Okay, so let's do this one together. Okay, first things first. Yeah, if you want to race ahead and finish, you may. Okay, 7, and then you have the next activity in the packet, so go for it. Okay, so 7 is here. I want to put him over there. And the way to do it, because it's on the bottom, is you have to multiply. So I'm going to multiply both sides of the equation by 7, and look what that does. I'm going to put parentheses around here. So I remember to multiply the entire side of this equation by 7. So look what that does. 7 over 7 is equal to 1. So this I can cancel out and say, oh, you know what? That's actually 1. So then that goes away because the 7 pops up over here. And I have an x plus 4 equals minus 3 times 7, which is minus 21. Okay. And then I'm going to have a minus 4, right? I want to put this 4 over there. So that goes away if we minus it. And then I have an x equals minus 25. Good. So look at what we did. We had an x plus 4, the whole thing divided by 7. So I'm going to multiply by 7 to get rid of the 7 on this side, but it pops up over here. That's okay. That's what we want. And then we have an x plus 4, so I'm going to take the 4 here and put it on the other side, right? Because we want all the numbers to be on this side, so we just have x by itself. That's the whole name of the game here. We want x by itself, so I can tell you, hey, that's what x has to be equal to for this statement to be true. Okay, and this statement may be, how much money your credit card is each month per minute that you talk, or something like that. So don't worry about where the equation comes from yet. We'll get to that. But I want you to get good and comfortable at being able to solve for x. Because at one point I'm going to say, okay, let's work on the word problem part. And then once we get down to this part, like maybe it'll be like this. I'll say, okay, now you already know how to solve that. Go for it. Okay, so let's go for it. So what do we do first? Well, the 3 is just with the x. Okay, so leave it there for now. Okay, don't touch it. This is the one you're going to start with. And you're going to put it over here. Remember, because if it had been, here, let me do this other one. If it looked like this, these are two different problems. If this is the case, what I'm going to do is I'm going to say multiply the whole thing by 3 on both sides. That's how I get this 3 to go over here. But in this case, the 3 is here. So I have to deal with this 2 first. And I put that on the other side by saying minus 2, minus 2. You see the difference? So if the x is locked up with addition and division, you have to take care of the denominator first. And you do that by multiplying to make the denominator go away, right? Because 3 over 3 is 1. Okay, so I'm going to turn that equal to 1. So then this goes away, and we have x plus 2 equals 3 times 3, which is 9. Okay, so let's go back to this problem here. Okay, just like this. All right, so I have a minus 2 and a minus 2, so I have an x divided by 3 equals 1. Okay, now I'm going to do the same trick we did down here. Okay, so I'm going to multiply both sides of the equation by 3. And I chose 3 because it's the one on the bottom. Okay, if this had been 17, I would have multiplied both sides by 17. Whatever I need to do to get x by itself. 1 times 3 is 3. And there's your answer. Good, 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 good. How are you feeling about this so far? Drop me a little note so I know how you're doing. We want to make sure that this is feeling comfortable, so you're feeling like, yeah, this is something I think I could do. Okay, we got 2 more. Tell me about this one. What is the first step? Don't write anything down. Just talk me through the solution. What would you do first? Okay. Did you say you would put the 6 on the other side? Maybe add 6 to both sides? Okay, good. Then what would you do? Then you'd handle the x. Good. So first step is handling the number without the x. We're going to put that on the other side, and we do that by adding 6 to both sides. I get an 18 equals 3x plus 6 minus 6. So that's 0. All right, and then we get here, what do we do? Tell me out loud, what are we going to do? Okay, we're going to divide by 3. Excellent. Okay, so whatever's in front of the x, you're just going to divide. And that will get the x by itself. That will give you x equals 18 divided by 3 is 6. Good. Hey, guess what? We only have one more problem. All right, here's the last one. And this is one that I would say would be a good problem on a test. All right, so here's your test problem. Ready? I'm going to do the solution down here. You're going to do your solution at the same time right now. Go, go, go. And then we're going to see if we have the same answers. Okay, so this is your last problem on the maze. Okay, I'm going to reveal in about 8 seconds. Three, two, one. How'd you do? Yay! Okay, if any of this made sense to you at any time during class, you should totally be celebrating because you know what? You did an amazing problem on your maze and you finally escaped. Yes! All right, hang on. Before you go, I have some things for you to do. Do you like cootie catchers? I know, some people do, some people don't. I actually have one for you for this week, and it is full of math problems. I know. So if you don't like cootie catchers, this is obviously not going to be your thing. But this was something that's not on, that we haven't done yet, but I thought it was kind of fun. But you're going to need somebody to do it with, and you're going to follow the directions and solve some math problems, and then they can check your answer by lifting it up like that. So that's your prize. That's also in your packet that you had for today. Also in your packet, can you scoot forward a little bit in the packet and go past the cootie catcher page and tell me, what do you see? What do you see? And let me pull it up here on the website so you can see it, okay? Okay, so we have a whole bunch of fun things for you, including, did you find your escape room? Yes, the escape room is in there as well. Yay! There's a couple of really cool pages just to get into the mood. There's like a fractions page, or no, not fractions page, I'm sorry. Wrong thing. I have an escape room for you, and so because I didn't have one for you in the recording from last year, so I put one in there for you this time, so let me show you where you can find it. All right, so we are on the math website. We are in Algebra Session 2. Remember, we are taking 2 weeks to cover every session because there's between 40 and 50 videos in each session, and the videos are between 3 minutes long to 45 minutes long, depending on what it is we're doing, okay? And so let me walk you through step by step. All right, so so at the top, so you're gonna go to Algebra, session number 2. The parent video, that's just for parents introducing what we're doing this week. Okay, and then do you see where it says Math Assignments Outline number 2? So you're gonna open that up, and these are the math assignments that you can do for session 2. So this is the same as it was for last week, right? Because we're in the second week for the second session. I hope that's not too confusing. Okay, remember, this is not a to-do list. This is a buffet. You're going to the ice cream store and you're picking out the flavors that you would like in your sundae, right? So these are the things that you get to work on based on where you are right now. So let me help you with that. If the content that we covered this was our review from the content we covered from last week, if this was enough and you're thinking, don't give me any more, this is plenty, I just need to work on this more. Okay, what you're gonna do is you're gonna work on the workbook. And the workbook is at the top, it says Algebra Workbook, and it's called Equations. And what you do is you can go up to the word Workbook, and you'll have to scroll down because all the workbooks are on this page. And so we have Algebra Workbook, and you're going to be in set number 2, Algebra. And then it's right here. It says Workbook Equations, and you'll open that up, and you'll start to work on it. Now, if you don't want to print them out, you don't have to. You can simply just view them and then use your math journal to write down your solutions. And remember, you don't have to do every single problem on every single page. You want to use the workbook as a tool. So when you have enough practice and you're like, okay, yeah, I get this. This is something I am getting consistently right every single time, and I'm not hesitating to do the solution. That's how I know I've got this. It's not you saying, yeah, I just don't want to do anymore. That's different. So you can work through this workbook, and this is the workbook we are going to be using for last week and this week, both in session 2. At the end, what I want you to do is do the 2-page review at the end. Okay, you see where it says practice test over there on the right? Practice test. Okay, so I want you to fill out the 2 pages at the very end, and then if you can finish them, you've got most of them right. Again, you're not hesitating. You can test out of the workbook. So that's how you know you've completed it. So beginners, this is really where we want you to be. Practice the concepts that we've been talking about in class, get really good at them, get really comfortable, and then when you're ready, you can move into the intermediate section. Okay, so what I had for you today, this is the packet that we had, okay? And so there was the maze that you were working on, this is the cootie catcher, and then there's your escape room, and you can enjoy escaping the math class, if you want to, I guess. Escape the math class. Somebody in the last class said, I don't want to escape the math class. What are you talking about? Okay, so that's in there. That's a fun game for you to do. On the last page, it actually has a place for you to put all your answers for your solutions, and you can work on that. Okay, so then the next thing I have for you is that if you're a beginner and you would like me to walk through step by step how to work through the workbooks. Like it just feels like it's too much. You're going to scroll down till you see where it says beginner. Okay, so then scroll down a little bit further. Do you see where it says Algebra Workbook Set Number 2? It says Algebra Equations. This is me walking you through the entire workbook. I don't do every single problem, but we work on every single page. And so if you have questions or you're not sure about something, you can just start up this video and you'll see that I walk through all of the problems with you. Well, I'm sorry, I walk through all of the pages with you and leave you to do some of the problems. Otherwise, I'd be doing the whole thing, right? And then I'd get the A. Okay, and then there's a video that will walk you through that as well. Those are the longer videos. Okay, and then we also have some other things in addition to the multi-step practice. We have converting units, which is important. We covered that a little bit more last time. And then if you are feeling like, okay, I got the workbook, I tested out of it, this was easy, I'm ready for more, Aurora, I've got plenty for you. I have all kinds of activities, everything from coloring activities to, what else? Here, actually I have a better slide than just browsing the website. Here we go. Here we go. I have the workbook, which you're going to do. We want you to do, I know it says 5 to 15 minutes a day. For your level, I would say 15 minutes, and then as many of those 15-minute sessions as you need to complete 4 to 5 pages a day is what we're looking for. And if you're enjoying it and you want to do more, sometimes the pages are just explanations, so obviously you're not doing any work on that page, but just make it work for you. So typically students in the algebra level, they are working, I want to say between 30 to 60 minutes a day on their math program, on their math, what it is they're doing for math on their curriculum program. Okay, and then we also have some fun activities. So you're going to be converting units, you're going to be doing some task cards, scavenger hunts, some more mazes, some coloring pages. It's a different maze than we did today. A puzzle train, he said, she said, so you have 2 people. One person said, hey, this is the answer, and the other person has a different answer, and you have to tell me which one's right. So that activity is in there as well. It's not all about getting the right answer, but sometimes troubleshooting it can also give you more ahas of, oh, that's right, and give you more connections if we come at the problem backwards. So that can be really useful as well. Word translation. So now we're starting to introduce the ideas of word problems and how we can translate like regular English words into mathematical concepts on a page. We're going to be working on this every single week that we are together because it's a skill you're going to need to develop. And then a round table, this is if you're working with 2 or more people, 3 people ideally, then you'll be able to work on a problem, pass it along, work on a problem, pass it along, and so you guys collaborate more on the problems together. And so that's an activity that is yours as well. All right, so if algebra is something that you are already comfortable with, so we just talked about beginners, you're going to work in the workbook. Intermediates, that's where the games, the challenges, the puzzles, the activities, the projects, all of that is intermediate, right? So we're taking those concepts and practicing and having fun with them. All right, if you already have a lot of algebra concepts down, and by a lot, I mean you're looking through algebra sessions 2, 3, and 4, which are already on the website, and you're like, oh yeah, I've done that. Oh yeah, I'm comfortable. And you can test out of the workbook pages for those workbooks that are associated with those sessions. I'm going to challenge you to go into the advanced section. Okay, so about 90% of our families say that the advanced section is the best part of the program. So make sure you don't miss this. So in the advanced section, this is where you find the practical applications. So it makes sense what you're doing and why you should care and what's it for. So I used to teach mechanical engineering at Cal Poly State University for many years before I started teaching math and science to K through 12, which means I've taken my lecture notes and physics and engineering classes and brought them to you. So I'm doing all the hard parts. I'm doing all the parts where you're not quite there yet. But then I'm also saying, look for where I'm doing algebra. Show me, let's work on the algebra part together. So I'm actually making it easier so you can start to build a bridge between the real world and the algebra lessons that you've been having in a math class. And that's what is so important. And unfortunately, it's a lot what's missing. So for this session, so there are advanced math labs in every single session. But again, we don't want you doing those unless you've got a really good algebra foundation. Okay, it's not meant to go beginner, intermediate, advanced, right? That's logically how it looks. I know, I'm sorry, I should have designed it differently, but that's not how it's laid out. We want you to do beginner, intermediate, beginner, intermediate, beginner, intermediate until you've mastered most of algebra. And then I want you to circle back and just do advanced, 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 because that way you'll be able to see a lot of the connections of applications of what we're doing. So let me show you what I have for you for this session. The first one is about black hole time travel. So these are real equations. This stuff isn't made up. And so I've got real data, real scientific measurements, and real physics equations for you. And I'm going to show you, what do you do if that, you see where that R is? It's buried in the denominator of a denominator within a radical, right? The square root symbol. Like, how do you deal with that? It's algebra. All right, so so we're going to be dealing with that. This is a real problem. You're going to be solving for, what are we solving for in this one? We're solving for a couple of things. We want to find the distance the traveler is from the black hole, and we're going to find out what the clock is going to do as we approach the black hole, okay, based on physics. All right, the next thing is I actually have these are some real photographs of meteor impacts and the debris that flies up after rocks, after rocks hit different planets, different objects in space. And we are actually going to be able to tell you how fast that thing was traveling, how fast the debris was flying, and how high it actually shot up in the air based on the energy of the impact. And so you're going to get to see that as well. Here is another one. These are comet trails. And so we have some data. This is real data. We're gonna plot it out. Again, we don't cover graphing for another, I think, 2 sessions. So again, you need to have some algebra under your belt and know how to plot and graph and know how to best fit lines before you tackle this one. And then we're going to be able to see how much water and how much mass a comet is using based on some data that scientists took. And then we're going to take a look at water on exoplanets. Exoplanets are planets outside of our solar system. We're going to use math to take a look at, do you see that equation? T is equal to the 0.6 T star, that's just another variable. R over D to raise to the 1/2 power. That's raised to the square root, right? We're square rooting the R over D. How do you deal with that? That's algebra. And so we're going to show you how we do that to answer real problems. Okay, good. Also, this session, there are bonus sessions in the math lab. There are going to be some pre-labs because we really want to make sure you understand the things we need to do before we get to the bonus labs in gravitation. So do watch the pre-labs first. Follow along. Whatever I'm writing down on that big board there, you're going to be writing down in your math journal. And then we're going to hop over. This is a freshman and sophomore level physics class in college on universal gravitation. So when you enroll in physics, this is what you're going to see. So I'm going to take it really slow. There's a little handout that goes with it, and I'm going to show you how we use algebra to start calculating things. And the reason I'm doing this one specifically is, so early on, is because usually when you do algebra, then you'll take a break and you won't look at it for a while. And then you'll go into like an advanced physics class and they'll say, oh yeah, those things you learned 4 or 5 years ago, you need to dig those out and be able to do them because I'm not going to go over them in class. But the professors will assume you know how to do this stuff. So I'm going to bring those professor classes to you now. I'm going to do the hard parts and then you're going to see, oh, that's where the algebra gets used. Oh, I get it. So there's a connection. So when you get on the other side, it's not such a surprise. Like, wait, I had to remember that? Really? So this is really going to help you make the bridge between what's this algebra stuff for, how do we use it, because honestly, algebra is used all the time. So if you're interested in being a scientist, an engineer, or even just understanding this algebra stuff from a different perspective, make sure you don't skip the advanced labs. They are super, super helpful, super, super important. In fact, I think session number 1 had 10 labs in them. So there's a lot. All right, yay! Okay, I am going to pause here. I've given you probably more to think about, and there's probably some leaking out of your head, so I understand. There is one more thing. I want to answer all the questions that have come in, and then I wanted to announce the math fair. So I'm going to do that here. Where is it? Oh, I see it. Okay, it was right beyond the exoplanets. I skipped a slide. Okay, other questions that are coming in. Yes, we do have the vehicle 0 to 60 lab. That is this week as well. You'll find that in there. If you like race cars, that's in there as well. And this is a photocopied page from my physics textbook from college of the equations for acceleration. And so there's exponents and there's unknowns and how do we use those with real cars. So we're going to take a look at that as well. Okay, and then I have one more thing. Can I just mention one more thing? I'm looking at my questions. There aren't a whole lot of questions I haven't covered. People wanting me to show you. I want to be a pilot. Yes, you need to join Civil Air Patrol and Young Eagles. Those are my 2 bits of advice for you. Yes, if I am still in a previous workbook, that's okay. Remember, this program is at your own pace, on your own schedule. This is not a race. You go at the pace you need to. If you want to join the live classes, that's great. But know there is always a recording. You can join us in Algebra and really in any part of our program. Good, I understand this, thank you. Okay, so there is something else I want to show you. So how many of you know someone that, you may be excited about math, but they are totally not into it? Do you know anybody like this? Yeah, it's like, Okay, so I had an idea. And I know it says due Sunday. I'm actually going to make it due like in a month. Okay, so just don't worry about this Sunday. It's not this Sunday. Okay, here's what I'm thinking. You are going to be invited to participate in our math fair. This is, like science fair have science projects. We actually going to do a math version. So this is your chance to share how much fun math can be with others around you. And your job is to help shift someone's perception of math from being scary or frustrating or boring or whatever the challenge is that they're having to being exciting and interesting by giving them an experience that's outside of a textbook or an endless drill worksheet of problems. Please just fill this out, right? Outside of a classroom setting, right? So most of us know at least one person who doesn't like math, does anything they can to avoid it, right? Usually it's because they didn't have a happy, positive experience when they were younger. So we're going to change that by doing a math fair. So you're going to help me create happy, fun, and engaging experiences for people to explore, discover, and this is where you come in. So what you're going to do is you are going to demonstrate a math concept or topic that you are interested in. So it could be in anything. And then you're going to create an activity, a project, a game, or do a demonstration or performance. Could be like a magic show, but math instead of magic. We want visitors to our math fair to experience math as they never have before, and it's going to be for all ages. So no matter what kind of education they have. So here's what you do. There's a packet. You'll get to download it. It's at the very bottom of the algebra page number 4. What you're going to do is you're going to select a topic or a math concept that you are interested in. It doesn't have to be algebra. It could be geometry. It could be fractions. It could be decimals. It could be just one concept, though. So that it could be multiplying fractions. It could be dividing decimals. It could be drawing a hexagon using a compass. It could be anything you want, but again, it's really narrow. It's only one thing. One thing. You don't have to pick from the list that I gave you, but it's just there to help you start to think of ideas. And then once you've got that one thing, what you're going to do is you want to think about one thing that you want your visitors to walk away from. It could be adding fractions, discovering how the number 6 shows up on dice. You could do probability. You could how to decode secret ciphers and secret codes, right? So keep it simple. We don't want to overwhelm people. This is one thing that you want your activity to be around. And then you get to design an activity with 3 things in mind. You want it to be totally fun. It's got to be engaging, something that captures their attention. It doesn't make them roll their eyes, right? And like, oh, not another math thing, right? And then it's got to be easy for them to participate, to learn from. It's got to be super simple, couple minutes or less of an activity, and then they're moving on to the next one, right? So I'm going to have a math fair. You're going to have a booth, and in that booth, it'll be online and virtual for our math family, and that's who's going to be participating. So yours can be a demonstration. People are asking about this. Yes, for people to watch. It could be a game you invent that people play. It could be a secret code you come up with that you teach people how to use. It could be a small project that you build yourself, an activity where others work together as a team to find out a solution. Anything you want to understand that one concept to have a happy, positive experience with math. Doesn't that sound like fun? All right, so what you're going to do is you're going to download the packet. It's at the bottom of this session for algebra. And then what you're going to do is work on it. This is in addition to the workbooks and things. This is something you can start to think about. And then when you've got it posted, there is a place in our Facebook student group, and you can post yours. When you post it, I will give you a triple entry. So 1, 2, 3 into the prize drawing where I pick people randomly. So when you participate in this one, normally you just get 1 entry. When you put this entry in, I will give you 3 entries. I'll put your name in 3 times. So when I do a random pull, if you know about probability, and if you don't, it's on the website, you'll be able to participate in that. So yay! So that's what I have for you. I hope this has been fun. If you have questions, I will stay here for a few minutes and answer them for you. When and where is the math fair? So it's going to be at the end of week, so I think let me give you an exact date because I have it on the website. And I'll put it right next to it so you know. So last year we only did it for a week, and the students had a fantastic time. This time we're going to let students do it a little bit more, and so they have more time to work through it. And, oh, thank you. Do you guys want to meet a pilot? Oh, come here. Wait, come back. You wanted me to pilot? We had somebody say they wanted to become a pilot in this is our algebra class. Hey, everyone. This is Al.
Hey, everyone.
Hi.
I'm Al.
He's our pilot in our science program. He's the one that takes your students up in an airplane and teaches them how to fly airplanes.
That's
so
right.
is math used in pilot?
All the time. If you want to be a pilot or build airplanes, you're going to need math.
Awesome.
And it makes it a lot more fun when you get to use math and then go up and fly. So, so listen to what Aurora teaches you.
Thank you. So later on, Al is going to be doing a navigation lab with you. So if you like maps and charts, he's actually going to be showing you how you use your math skills to do some navigation. So that's a bonus that's coming for you as well. All right, everyone, I think we just about finished. We went a little longer than usual. I'm so sorry. But you got a lot of value out of today, right? Has today been something that's been of interest? Okay, so what you're going to do is you are going to dominate the conversation tonight at the table. You're going to share something that you learned in class, something that you're excited about. Could be any of the projects we did or something that you're excited about working on, like the math fair or the black hole time travel or any one of those things. And you're going to talk about it. And then you're going to let me know how it's going in your family. So feel free to send, you can snap a picture of the work that you're doing, submit it to me by email, aurora@superchargedscience.com, or you can submit it to the Facebook group, which I prefer because then other students can see your work as well. And so you can just photograph your work if you want your smiling face, that works too. Either one is totally fine. And it's going to be so much fun this week. Algebra, easily one of my favorite subjects. I could be doing algebra all day. And if you want to know, do you want to know a secret? You want to know a quick little story? I'm gonna do a story next week for you. I know we ran out of time just because the reviews tend to take a little bit longer. The first time I did Algebra 1, I actually didn't pass the class. In fact, I had to go to summer school. So if this is something that you've been feeling like you're struggling with, you haven't, so take it from someone who has struggled, who understands where the struggles are. Yes, so that was me, and I went to summer school, had a fantastic teacher, and she was amazing, and it was just, I couldn't get enough of it. And so we did an entire 9 months in 6 weeks, and I thought, why don't we do this normally? So that's why this Algebra 1 course is in 4 months. We're taking more time to do it than 6 weeks, but and we're also not meeting every day, and it was a very intense experience, but I learned it, and that total immersion, there is really something to that. So just completely immersing yourself in the experience is really important. I also want to give you enough time to work on stuff too, and to kind of think about things. So that's why we're doing a 4.5 month class. So if you have questions, let me know. Aurora@superchargedscience.com. Yeah, I got an A+, just so you were people that are asking. Yes, I did pass the second time, and every class since then. And actually, I did so much math. When I got to my high school, they didn't have any math classes for me the last 2 years. Is that right? 1 or 2 years. They didn't have any. I already finished everything they had. And so I enrolled in my local community college, which I know is more of a thing now, but 30 years ago, it wasn't a thing. Like, people didn't do that. And so, yeah. So anyway, so I took extra math classes at night, which transferred directly over to the university when I enrolled in the following year for fall. So as an engineering student, when I went to mechanical engineering, when I was working on my undergraduate, there was only, usually engineering has like a lot of math classes. Usually I have to take like 2 years worth of math, actually 2.5 years of math. I had finished everything except for like one class. And so I walked into a junior level math class when I was a freshman. I would have to say I don't recommend that, just because what's the rush, right? You're going to college, it's supposed to be fun, you're supposed to be able to study with your friends. If you do all that ahead of time, what are you going to be doing? So I would not recommend that approach. I just did it because there wasn't any math classes, right? So in retrospect, I would have taken other classes. I wouldn't have taken more math. Even though I love it so much, I would have taken more applications of that math class, which is why I walked into the wrong class. I thought it was a rocketry class, and instead it was how to fly airplanes, which is how I became a pilot. So I would have done more of those. So there's a lot more opportunities these days than there was when I was going through school. So if you are loving math and you're feeling like you're a little ahead of the class, I would say, I'm answering some of the questions that are on the chat right now. I would say start challenging yourself with other things that incorporate the math that you already know, so you can make more connections that way. And so So there's FRC teams that you can join that are high school. There's VEX V5 teams that you can join if you're in junior high. So there's other things. There's robotics. You can join Civil Air Patrol if you're interested in flying airplanes. And so Young Eagles program does the free flights for kids. And so that's one that you can find in your local airport. If you're interested in astronomy and astrophysics, we do a lot of astronomy labs. I want you to find a local astronomy club in your area where you can go and start talking to astronomers. So start branching out beyond just the little bubble we call math, because math is the language of so many other things, science, engineering, and we want you to start having those experiences. That's why the math course isn't just strictly math. We are doing science. We are doing microscopes this week. We are doing, what else are we doing? Black holes, time travel. We're doing all kinds of fun things, a math fair. So education, outreach. We're doing a lot of different things because math just doesn't happen in a vacuum. You need it for other things to make sense. I'll tell you about the beaver next time, the 87-foot beaver. Okay, so that I had on my homework. Okay, are you guys ready? Ready for your work? Okay, if you have questions, you're going to let me know over at superchargedscience.com, and I will see you next time. And don't forget, your class with Doug is on Thursday, and your study hall, if you're participating in that with Leah, is on Friday. And I will see you all soon. Bye-bye.